Yes. Okay. Thank you. Okay, thank you very much for the kind invitation, for inviting me to this very important workshop on evapotranspiration. So I'm going to talk very briefly about evapotranspiration and crop water requirements assessments exerted in southern Italy by means of the FAO program crop water. Why this approach? Because after the application of the Water Directive 2060, there has been a new legislative framework for community action in order to ensure sustainable water use, mitigate the effects of floods and droughts, and the involvement of stakeholders and public opinion. So the first thing that Italy, as a EU member state, has been required to do is to subdivide the national territories, existing national territories of basin authorities into hydrographic districts. And the one we are concerned today with is the Southern Italy Hydrographic District, which is called Appennino Meridionale. And so one of the most important things was the elaboration of a specific water management plan, which has been approved in December 2021 as required by EU directive. This is a very important planning document because it is an element of strict conditionality for the use of new European funds for the development of new irrigation projects. So it is very important. And so the proper assessment and estimation of crop evapotranspiration and of relative needs in water are a compulsory aspect for the management of water resources. In this study, the analysis has been focused on irrigated areas which belong to the hydrographic district of southern Italy, both served by service providers, irrigation and land reclamation consortia, and areas relying, on the other hand, on surface and groundwater resources exploitation. The data, information regarding the extension and features of the irrigated areas has been provided by aerophotogrammetry photos, 1 to 5,000 of agricultural areas belonging to the hydrographic district. These photos have been provided by the National Italian Agency for Financial Support in Agriculture. So after a thorough standardized process of photo interpretation, it was possible to bring all this data, this information on a GIS system, which has allowed to define areas where irrigation is mainly carried out by means of irrigation service providers, which is the photo you can see here, and areas where, on the other hand, irrigation is mainly based on self-suppliance, and that means surface or groundwater exploitation, which is very important in order to have an idea of what is the pressure on natural resources, in this case on water. So the following step was to describe the utilization and the efficiency of water resources, so to have a proper assessment of the crop water requirements. Because of the vast use it has proved inside the scientific community, it was decided to use FAO's crop water program, which is considered to be one of the most reliable software for, at least on a large scale, for the assessment of crop water requirements. Of course, as you all know, computer software decides for irrigation planning, for irrigation scheduling, and its basic features include the calculation of reference evapotranspiration and the amount of water needed by the crops. The software runs a daily water balance, so I will go very, very quick on this, assuming that all of you are familiar with this program. And it is based, of course, on the FAO famous official paper, FAO paper in 1956. And the program provides the opportunity to input data with monthly, decadal, or daily values for temperature, relative humidity, solar radiation, and wind speed. Most of these values have been provided, in this case, in this study, by the database provided by ClimeWatt, which comes along with CropWatt. And it has over 5,000 climatic stations from all over the world. And here you can see some of the stations that ClimeWatt provides with data for Italy. Of course, according to further calibration and better data, we also made a comparison between data provided by these stations with data that were available inside the hydrographic district territory. And in this case, you can see here a map of the pluviometry and meteorological stations that are available with this kind of data. And we have made a comparison, and the difference we observed in cup water requirements was not very significant, just ranging around 3%. So it was very useful to use this additional data. Of course, crop evapotranspiration during the growing season has been calculated from reference evapotranspiration and crop coefficients, all as established by procedures FAO in paper 1956, according to the following equation. On this regard, FAO has produced updated values for KC all over the world, which can be used. But I will come back on this. In this study, we also have been using a local KC based on bibliography references and local field trials. So the reference evapotranspiration ET0 has been calculated on the basis of climatic data relating to temperature, humidity, sunlight, radiation, and wind speed. Other climatic data, as you can see, of course, have been regarding precipitation as well as effective rainfall. In order to have, of course, a proper assessment of crop evapotranspiration and to calculate the soil-water balance, other parameters have been entered into the software in order also to consider eventual reductions in yield due to stress. And these are aside from, of course, from KC and length of different phases of the growing season, group dirt, critical depletion fraction, and the yield response factor, KY, which is being analyzed and studied by FAO papers 33 in the first basis, and especially later by FAO paper 66, which was cured by Pasquale Istituto. So all of these parameters have been inputted into the software. Of course, the software also takes into account planting and harvest date of every crop, the height of the crop, and millimeters of useful rain. In this study, the percentage of useful rainfall has been, of course, it can be calculated according to various methods, such as the FAO AGLW formula, but in this case, we use the USDA formula. And also considering that the evaluation of the readily available water in the soil, which means the water which is available between field capacity and wilting point, and because of and the water infiltration rate, of course, depend on soil properties. As you can see here in this slide. Of course, in order to have adequate runoff estimates, we have gathered data regarding the soil features and characteristics in different areas of the hydrographic districts considered, of course, based on field trials, on bibliography, on papers, publication, and so to have proper information on the total water content available to use and its maximum infiltration rate. Other necessary information required were the maximum rooting depth and the water content of the soil at the beginning of the irrigation system. Of course, when site-specific information were lacking, in some cases it has been generally assumed to be operating in medium textured soils, except, of course, for well-known situations such as those occurring in coastal areas or in a river basin where generally texture can be ranging from sandy to loamy or silty and so on. And so with this information regarding soil moisture content, evapotranspiration, there is the effective soil-water balance was calculated by the software. And the program, of course, as you all know, allows for a daily or a multiple day basis according to irrigation scheduling considering to be adopted. And you can see here some examples of the irrigation scheduling. But as I was saying before, in order to have more precision on crop water requirements, we use KC, which, as we know, are notoriously affected by environmental conditions. We use local KC all over the territory, in different provinces, in different regions of the territory, in order to have more accurate estimates. And here you can see an example. This is for Campania region. Now, the total cropping pattern as required by the crop work program was defined by the total amount of the areas cultivated with every single crop, which was expressed as a percentage of the total irrigated area belonging to the province. So, for instance, on this slide, you can see that the olive tree occupies 37% of the total irrigated area of the province, the fabas 13%, table grapes 10%, and tomato 7%, and so on. How we derive this data? We, of course, after photo interpretation of the photoaerogrammetry photos, we derive the percentages and we apply this data inside the global crop pattern required by the program. And so the next step was to sum all the irrigation deficits carried out by the program, calculated by the program per each single month and for each single crop, as you can see here in the red circle, and multiplying these values for the cultivated area, the total hectares of the area which was cultivated with olive trees, and so to have a total irrigation crop irrigation requirement and the total for each province. So for each province of the territory which is ruled and administered by the hydrographic district, we have gathered this data. Of course, the assumption was that all of the areas concerned by irrigated crops, as derived from available photos of AGEA, were part of a wider irrigation scheme, and which is also very interesting because the program also gives us information on which is the highest percentage of the area and which month. In this case, it is in 92%. It is the highest percentage in May and 92% also in June, according to the crop calendar. And where the highest irrigation volumes are to be provided, which in this case for the province of Foggia is during the month of July. So you can see 3.4 millimeters per day and 105 millimeters per month. And net scheme irrigation requirement is 0.39 liters per second per hectare, which is what you can see here in this graph. So it was possible by means of this elaboration to calculate the water deficit, potential evapotranspiration in all of the territory of the Southern Hydrographic District in March, April, May, June, July, August, September, and October, and throughout the irrigation season. So you can see, this is very important. I think this is one of the most interesting results of this study. We have information regarding areas irrigated, regarding evapotranspiration, potential evapotranspiration in irrigated areas which are supplied by service providers, and evapotranspiration, it is zero in irrigated areas where self-sufficiency is occurring, which means surface or groundwater. This is very important because you can see there is a lot of irrigation along the coastal line, and this is, of course, environmentally, this is very, very critical because we are facing, of course, few years now, very important problems of soil salinization and the integration of the saline water inside the water table. So some data, you can see here, the total of the irrigated areas with collective service is around, according to the study, in the irrigated Southern Hydrographic District is at more than 200,000 hectares, compared to areas irrigated by surface groundwater, which is more than 600 hectares, so about 3 times bigger. And regions which in the Southern Hydrographic Districts are especially Apulia region, Campania, Calabria, and Basilicata, which is what you can see here. This is Apulia region, this part of so it's the hill, the widest irrigation area, and then it comes Campania. This is Naples area. Then we have Calabria, which is Reggio Calabria, and so it's the toe of the boot. And then we have Basilicata region, which is on the Ionian Sea. These are the areas characterized by the surface groundwater highest values. So this is environmentally, this is very important. And so if we go have a look at the crop water requirements, we have that in areas irrigated by service providers is more than 800, close to 900 million cubic meters, and it's almost double, more than double in areas irrigated by surface and groundwater. So it's 1.6 billion of cubic meters, according to the study. Of course, again, the most important regions are Basilicata, Calabria, Campania, and Apulia, which is what you can see here. So the highest amount of water required is in Apulia region, which is the driest region, of course. Calabria is the second one, even though they have a different orography. They have more water, but of course it's way down southern. So they have a higher evaporative demand, so they have higher demand for water. Then we have Campania, of course, with almost 200 million of cubic meters per irrigating season, and then we have Basilicata. So what is the final result? I will be very quick on this. So this data, this information are very important when it is necessary to adopt decisions regarding the use of transboundary water resources within the hydrographic district between different river basins. So this is why there is a program agreement since 1999, for instance, between coordinated by the Ministry of Infrastructures, where the main actors are Basilicata Regional Government and Apulia Regional Government, which are these Apulia and Basilicata for the sharing of water resources. So what is the mandate? To coordinate and implement the agreement, adoption of water resources assessment plan, determination of water shares between the different basins, between different regions, regarding uses, amount, prices, and tariffs, environmental measures, and soil and water resources protection. There is an executive committee, of course, which is interested in programs for utilization of shared water resources, adoption of measures to face and to cope with drought, efficient implementation of the schemes, determination of water costs, approval of programs for the utilization of tariff revenues, for instance, environmental measures. So the objectives, finally, are the assessment of the water resources demand for the two regions, analysis of infrastructures and schemes in order to optimize efficiency in the storage, convenience, and final delivery of the shared water resources, permanent coordination and monitoring of programs, plans, and activities for the proper management of shared water resources, assessment of water costs for the different use in order to have defined and adequate prices and tariffs, and the approval and appraisal of necessary measures and intervention on the existing schemes and infrastructure in order to allow for a full accountability of the shared water resources, and of course the recovery, use, and saving of water resources by means of its different uses. And this is also, I thank you for your attention, and